Hello, ladies and gentlemen. Thank you for joining us again. Apologies for the delay in starting on time, but here we are. We are about to start yet another exciting session on the 30 days of learning of data science, where we teach you how to build a fraud detection model. And I have here with me Nasiruddin Rahim, who will be walking us through this. I mean, personally, I am looking forward to everything here, and I can't wait to have you all learn and practice alongside with us. Just to put it into perspective, this is a series. We 2 days ago we built salary prediction model. That's a regression model using Python and deploy using Azure function. Today we're going to be doing fraud detection, and next week again we do yet another model which is all supervised machine learning. We believe that if you go through this series of projects and hands-on exercise using Python and Azure, then you can master and build your skill significantly. Permit me to welcome and introduce to you Nasruddin Rahim, who is a student ambassador. Hear from you. Hello, Nasruddin.
Hello.
Can you hear me, Nasruddin?
Yes, I can hear you.
Yeah.
Hello. Yeah.
Yeah. Good afternoon. Can you introduce yourself and just talk a brief about yourself before we go live?
Yeah. Good afternoon, everyone. So my name is Nasiruddin Rahim from the Polytechnic Ibadan, a student Microsoft Learn Ambassador. I'm also a data scientist and a new cargo expert. I've been able to work in some industry as a data scientist, whereby I build predictive model in order to save the business from a lot, in order to save business and try to maximize business profits. Yeah.
Great, and also congratulations on being the recent cargo, expert in notebook. I see your work every time. We're proud of you and what you're doing, contributing to the community. And over to the chat area, I want to say some shout out to each and every one. So feel free to tell us where you're joining from. Sri Vanas from Vameti, thank you. Vanetti, thanks for joining us from Dubai. I see Tiago joining us all the way from Norway. Thank you everyone for joining. Feel free to introduce and tell us wherever you're joining from. I also see right here Ifeanyi Ezerioha joining us from Nigeria, and here we have Devrashin Gohir joining us from India. Permit me if I'm not getting the name right. I have Versus joining from Dubai. Thank you, everyone. Please keep commenting. I will want you to engage fully, not just to engage, but also to share with others. So right now we dive in and go straight to what we have for today. Nasruddin, can you zoom so that we can have more view from your notebook and then walk through this together? So I'm going to be passing this over to you shortly. All right, I think we have this view, and I'm also going to make it bigger. I think this is awesome right now. All right, over to you, Nasruddin, as you walk us through how to build the fraud detection model in Python.
Yeah. Good afternoon, everyone. So I greet everyone from various continents, and I'll be walking us through on how to build fraud detection model today. So the introduction mainly is just that we want to be able to save our technical debts in our company and be able to reduce it. So what we are trying to do is that we want to have a machine learning model that will be able to capture people, maybe some fraud that is happening around based on a lot of features maybe we try to have in our data set. So that's the major goal. And the major goal of what we are doing is that we want to save the business and we want to maximize the profit. We know what it takes to try to have technical debt or incur loss in your businesses. So yeah, and what we'll be having that we are going to be having a good add-on section on this. So technical debts are part of the requirement that are omitted, not done or low at a priority of importance. So we should really take note of that. And we have a lot of the causes of technical debts. We have the rush, we have the bad code, we have the intentional. So sometimes we might choose the to incur technical debt for strategic reason. So we have the types of technical debts. So sometimes we might try to take the easy way out. So we might try to change the requirement that may need new tax. So adding a small increment in price by multiple team members with proper understanding of code structure and yeah. So some technical debt we must pay. We must try to maybe untested code, pardoning contention and stuff like that. So tips to keep technical debt under control. So we are going to think twice, have good code review, and yeah. So we want to be able to avoid technical debt now, and this is what we are trying to be. So I'm happy to get started on this and trying to walk us through the data set you have in order to see some real life applications of technical debts and to make our clients happy. So
Yeah,
yeah.
sorry, Nasruddin. Just before we move forward here, I just want to do a bit of clarification or add more to this topic of technical debt. Uh, when we talk about technical debt, this is not a beginner's concept. Because as a beginner, you're just building machine learning, you're not paying attention to many things. But technical debt is mainly what you introduce into the business. It's technical. You are the one, because you are rushing to write your code. You are writing a bad code where you don't even pay attention to commenting, to do things like that. And this literally, and some people can even intentionally put some clauses in the code so that when they leave the company, they can go back to fix and get paid. And some can be accidental, some can also be due to the way you write code. And that is what we want you to also bear in mind as you continue to build your machine learning model or train your algorithm and work for organizations. You need to be aware of technical debt, which are debt you can cause an organization due to the way you do your project. If you don't think twice, before you write your code. Which is why it is advised that whenever you're writing code, you should think twice and code once. So if you can think twice and you code once, you get it well. You have to do code review. When you are done writing code, get someone to review it for you. You leave time in the sprint so that you can actually check through, and deal with any technical things you think you don't know, those gaps. In case you come across something, I don't know how to do this, give yourself some sprint review where you can actually study those things and go back and do the work. You don't have to complete everything without learning. Some you might able take 1 week break to learn so that you can avoid those debts, because those debts can cost more than what your code is solving. You can solve a problem, but the debt you are creating by the way you write your code, by the way you document it, by the kind of things you do, can cost your organization more. So take this as a technical concept or advanced concept that you're adding to whatsoever you're doing, bearing that in mind that when you're building a project, you need to consider, am I not creating a technical debt by the way I'm doing my project? So having said this, we are moving next to the real case study that we have for today, which is the fraud detection model. So Nasruddin will be walking us through how we get the data. So all the notebook, how we read the data, how we get the data, he will be talking to us about this, and we can move on to build the algorithm, to build the model and train our algorithm. Thank you, and over to you again, Nasruddin.
Yeah, thank you so much. So the data we are trying to build a fraud detection model, and the data is being collected from one of the failure platform in order to for open data. So I'll be walking us through the fraud detection model, and in the executive summary of the project we are trying to fine, we want to have a model that is going to capture the real cases of debt we are having. In a particular organization, you are working as a data scientist. Your main goal is to build machine learning model to solve business problems, no matter how the sophisticated model you are trying to use, no matter how you think your code might be neat or your code might be rough. You are there to solve problem and to maximize the profit. So fraud detection is very applicable mostly in the financial industry, whereby the little fraud you are having in your company, you want to make sure that maybe you want to eradicate fraud in your company or try to reduce it as much as possible. So that's the purpose of trying to use machine learning algorithm in order to help the woman, maybe the customer service or the financial people, in order to interact better with it. So let's get started with reading our data set. So the data set is very large, which cost is above more than it has a millions rows. So we try to print the shape of this data set. Now, in order for it to be reproducible and for it to make a lot of easier, we are going to take a sample from the original data set, because we observe that the data set we are having is more than 1 million. So we have to take the sample from it, and we are going to be selecting 10,000 samples. So, and part of the, we are trying to take random sampling, which is going to be stratified, in order to make sure that the 10,000 we are taking from the total millions of rows we are taking from does not really affect our rare cases, which is the one. So in the further study, we are going to learn about what the rare cases actually means. So here we are trying to take the sample from the original data set. And after that, in order for us to get, because the sampling takes it, maybe these are random sampling techniques, simple random sampling techniques. So whereby there's equal chance for every row of being selected. So the random state is for it to have a reproducible result. So when you are trying to select your sample, maybe from China, maybe from America, we are going to get the same results right from our notebook. So we are going to reset the index in order to make sure to avoid future error when we are trying to play around with our data set. So let's check again. We now observe that fine from our original data set, we now have 10,000 rows and our columns still remain the same. And then we want to look at the actual point when we try to sample our data. What is the probability of the rare cases we are having? So the rare cases, 0 means that it's a non-fraudulent case. Why one means it's a fraudulent case. So we can observe here we have less than 1% of fraudulent case in when we try to sample our data. And from the original data set, that's the same too. So I think the simple random sampling we take here has already justified the probability of what we have done so far. So let's try to save our data set, and then we are going to move next to the notebook, whereby we are going to see the real data science process in solving this particular problem. Yeah. So I welcome you to the modeling part, whereby we want to save our company.
Sorry, Nasruddin, just before you move forward, I just want to notify, yes, I got some question. Will the notebook be made available? Yes, we will make it available. One. Number two, what we've just done is to select sample from the original data. The original data is about 222 MB, large. You can imagine how big it is. So what we rather do, okay, this is the data, you can randomly sample using some statistical approach from that huge data, millions of rows, and take some from it. And that is what we've done now. And we exported sample we took into CSV that will now be imported right here. So to a lot of you, when you get the sample from there to that each file, which you're going to share the details, continue. All right, over to you.
Yeah. Yeah, so we are going to get started in trying to now follow some process in machine learning. So I'll be starting the process. We are for trying to identify the business problem we are having. So we are going to get some little understanding of the data set we are trying to use in building our machine learning model. But the first, we have to import the necessary libraries. So we've seen various these open source machine libraries, the NumPy, the pandas, and then I'm going to use one of the favorite one favorite data visualization tools in Python, which is Plotly. So, and we are going to just be looking at mostly theory models. So I actually selected this model, okay, logistic regressions, which is traditional statistical model. Then move to random classifier, which is a gradient boosted model. And then we move to the SGBoost classifier, which is extreme gradient boosted models. And then at the evaluation metrics, we want to look at how to solve our problems, whereby we have some little issues, whereby it's going to be explained later during our code. And we have the likes of omission matrix and classification reports in order for us to be able to debug the models we are using. And we are trying to pick our model. So let's get started here. So we are trying to run our original data set right now. And in checking the head of our data set, we observe we have a lot of features that are being related to maybe someone we have fraud or not. And then we can see that we have the last column with the target features, which is called is fraud. So when it is 0, that means there is no fraudulent case. And when it is 1, and that is a fraudulent case. This is where the problem comes in. In the real world sense, most companies where they get started, they try to track maybe their fraudulent activities, maybe just based on amounts, and might not always be that, because if you are trying to, okay, fine, you always want to use amount to declare fraudulent case, you might lose a lot of customer, you might lose a lot of money in your business, and you might just, the startup or business might fold up very soon. So this is why we want to employ machine learning models in order for us to detect, despite various features we have in our company, in order for us to detect the fraud. So let's check our data set. And the first thing we do as a data scientist is for us to investigate our data set. So we have to know the data set you are playing with, is it messy? Is it a data set that is already cleared? Does it have any missing value? Does it have some features that is not incorporated what you wanted to do? So that's the first thing we are doing. So the first thing is that we want to check if there is missing values across the columns, across row in our data set. So we observe here that, okay, fine, there is no missing value whatsoever in our data set, which is something that, okay, fine, is well. The reason why we have to check is that there are some models that they can't treat missing value on their own. Missing value can also try to be something that in order for us to debug the data we are trying to use. So in the real world sense, is this particular column supposed to have missing values? Do we have to go back to the people that maybe a data engineer in your company, or where do you try to smooth data from? So that's why you have to check the missing value. So the next step is for us to check the various data types we're having in our data sets. And these are the various data sets we normally find in our data set. We have the integers, we have the object, the categorical features. We normally have the floating number, which seems to be continuous features. And then, so this data does describe just for us to show the summary statistics of maybe someone, maybe the data set data types is a float on an integer. So I'm looking here, let's just try to check one thing alone, and the amounts. So I'll just focus on the amount because we can relate well with the amount. And if you observe here, the maximum amount of dollars we have here is for $4,430, and the average amount across various amounts is up to just 70 US dollars. So that we are having here. So let's try to move to the next step, which is exploratory data analysis. We want to know what is happening in our data set. So we can't just, okay, fine, I want to take my data set and try to put in the model. No, we have to know what's happening in our data. So when we have a good machine learning model and when we have a bad machine learning model, we are going to know where to work to and how to see what is happening. So the first thing I will be looking at is that what is the proportion of the fraud detections. So I'm going to be using Plotly here, and then.
Sorry, Nasruddin, can you zoom again a bit? Or can you hide the tab? Okay, okay. I think it's a bit bigger.
It's a bit, thank you. Yeah. So the question I want to find, we have a fraud detection data set. What are we trying to look at? So we want to know the percentage of fraudulent activities and the percentage of non-fraudulent activities. So we observe here that 94.4% of our of the data set means no fraud, and we have 0.59%, which means it's less than 1% of fraudulent activities. And despite the fact that we have that, we want to be able to reduce it as much as we can, as not to incur them, because this particular less than 1% might cost a business a whole lot of $1 billion. So we have to find a way to tackle this and know what are the features to contribute that contribute to maybe someone is going to have a fraudulent case. So in a nutshell, the problem we are solving, we are dealing with, is an imbalanced data set. This is extremely imbalanced data set because it's not like 50-50 balance between the positive and negative side, and our rare case is even less than 1%. So fraudulent model is something that is very sensitive, that before you try to say you want to deploy your model, you must know what is happening with your model deep down, as not to spend a lot of money and you eventually find okay, the model we use is not something that can even detect a single fraud in our company. So the next thing I'll be looking at is we have the lot of categories that have been included in data sets. So the highest category we have is people trying to maybe use the amount for grass transport. We have people that use home. And the lesser one is for maybe travel activities. So let's check the next thing, which is the amount distribution. So what is the total amount? What is the average amount? We also observe here that fine, our maximum amount is around 4,430, and we have a lot of outliers in our box plots, and which is something we can also look at maybe when we try to improve our model, because outliers treatment is something that advisable in the data science process. So I want to roughly check this. Okay, fine. The company we are trying to solve, can we just solve this problem trying to know the amounts? And we say, okay, fine. Maybe if the amount is more than a particular threshold, fine, this is a foreign activities. So instead of trying to spend money or trying to spend a lot of cost on trying to build machine learning model, on trying to monitor our machine learning model, can we know it from amounts? Let's check it. So I try to do something around this, and I know, okay, fine, for any fraudulent case, what is the descriptive statistics around it? It's been observed through amounts. It's been observed that even this 4,000, the IX amount we have in our data set is not a fraudulent case. So amounts alone is not something to look at. So there are a lot of features, there are a lot of random errors that that captures maybe someone is going to have a fraudulent case. So what we are dealing here mostly is this one, the fraudulent case we are having. We have to make sure we use it. We have to have a model that's going to capture it and to save the business from it. So I want to check the demographics. We have looked at one of the major important is fraud. We have looked at some socioeconomic status, because amount is something, okay, what are the economic status of the customer we have? So we want to look at the demographics of our customers, the gender variations. So it's been observed that we have 55% of our total customers to be female, and we have 45% to be male. So you can see the range between them is just is 10%, which is something fine. Yeah. So all what we have done is trying to look at the variable at a time. So let's just try to look at bivariate analysis. So trying to compare two variables at a time and see what's happening in order to assist us when we want to build our machine learning models. So the first thing I'll be looking is average amount per category. So we have a lot of category in our universal analysis, and we know that gas people in our company do a lot of gas transport. And then does that mean that because they do gas transport, does that mean that they are spending much amount on it, or what is the average across those categories? So this leads us to trying to have this kind of blackboard. So we observe that even the one that has the highest frequency in our category does not mean that it's the one that has the average amounts across all that category. The one that has the average amounts, highest average amount, is the grocery POS. If we can also, that's why we have lesser people that they are traveling. The traveling amount is more costly, because the average across those traveling amounts is 89 points. It's more than even the grass transplant. So these are the various ways to look into our data sets. Now, this is the little bivariate analysis we are going to be doing in this section. So let's move to feature engineering now. So what we are trying to look at is that we have a lot of features in our data set. We have the 6C number column, which is a particular serial number, and then we want to see if this number really actually makes sense to our model. And there are various encoding techniques we can use in trying to have a good data set into our model. So one of them is, we have one-hot encoding, we have label encoding, we have count encoding, we have a lot of encoding techniques. So, and most times we should always be careful about the low cardinality features and high cardinality features. And the frequency, the CC number has a lot of high cardinality features. So mostly important is that you might actually try to have it in an encoded format, so in order to capture that particular features. So it's going to count, maybe it's going to count, so when a particular thing occurs 10 times, so it's going to replace it by that number. So when we want to test our model later on, it's going to send that from a particular data set. So we also have the next thing, which is our date time, the transaction date and the transaction time. So we want to know the hour in which it's been transacted. We want to be able to know the date of birth of our of our customers, and we want to know their age. So there's a lot of features now we can do incorporate into our models. So we have the dates, but they don't give us the age on date of birth. So we can actually get the age from all these kind of features. So we have a lot of data set we have, and when we want to build a machine learning model, you only have this kind of intuition in the part in that particular domain. What are the features for you to use before you even try to be scientific? Because data science is both of art and science. So you have to know the art part by trying to talk to the people in the art that has the domain knowledge, and you must be make sure you have that accurate domain knowledge in what you are trying to solve. So a lot of features has to be dropped, like the first name of the last, the gender. I'm very sure why this gender might actually be job is no, we have this kind of issue now. We have a lot of things going around, maybe trying to have this kind of bias between both genders. So most times we try to remove the gender in order not to reduce the biasness in the model we want to create and to help the business better. So after that, we dropped some inconsistent features that we might find that it's not going to be compulsory for now. And the big difference is just about data science is that it entails a lot of experiments. So later on our own, you can try to look at these features and try to see a way to make sense from these particular features. So let's try to convert our category features into a dummy variables, which is one-hot encoding, which is part of the encoding techniques. Since the count is less than 20, so we can actually take dummies that can find if this particular row is a if this particular row is travel, other rows has to be, that means that they did not travel. So when we have 1 year, others will be zeros. So we have something like this. So we can try to look at our notebook now and see the head of the shape we're having. So that's why we have we still have our 23 shape, we have removed our features, but we see the one of the encoding. So this particular row means that category Mike POS, that's what they use the money for. One other we have zeros. So we are moving to the stage of building our machine learning model. This is where the fun part seems to be, and then we are trying to look at what will happen. So now we are trying to see how to split our data sets. So we want to select our X and Y variable now. This is what you have to do is just that we are trying to build a machine learning model. We have what we call the dependent and independent variables. So our dependent variables is our which is fraud. It's what we wanted to minimize. We want to minimize the foreign activities. And the X, which is our independent variable, are the explanatory variables in order for us to detect the fraud. So that's why we have this something X and Y here. And we want to split our data set into train and test data. So the reason why we are trying to define, we don't want to be the model that's okay, fine. We want to be the model that has 100% data and we want to test on that particular data set. It's just that you are trying to cheat the model, you are trying to cheat the business, and then the beauty part is just that if you do this and you try to spend a lot of cost in order to monitor your model, to deploy your model, 100% you are not doing the right thing the right way. So it's better for us to train our model and test it on the data I have not seen before. Then we can try to compare our predictions with the grand truth of what we have. So in order for us to be able to find this, my model is doing better. And in general form in statistics, we call it predictive power. We want to know the predictive power of our machine learning model. Is it 99% accuracy? Is this something that we can go in with? So we can talk to the stakeholder. Okay, fine. We have this kind of model now. It's time for us to deploy into a model and to make our business to be able to detect a lot of fraudulent activities and maximize the profit. So we are going to use 70% to train our model and use 30% to test our model. And then I'm going to use just 3 models here, which is something that is going to be tested on logistic regression, random forest, and XGBoost. And I'm taking this note now is that I'm not going to add the model, okay, fine, in order to us to turn the parameters. We want to see them by their default parameters. And one notion here is just that hyperparameters tuning is something that is very important in data science domain, but sometimes we should be careful about the complexity hyperparameters tuning might brings into the problem we wanted to solve. So if the model default parameter can solve a problem, why do you need to tune the parameter? So we should be very careful about that. And let's move that. So we have a function that is going to evaluate our model based on accuracy score. Before I move to the next stage, I want to have a question. Is accuracy the right metrics for what you are trying to do? We want to reduce fraudulent activities. Can we actually use accuracy score to measure the metrics? I want to see what is the yeah.
Yeah, so while we wait, to see response to this, I felt based on the comment I have in the comment section, speaking about maybe speed seems we're a bit faster. So I'm just going to sort of summarize what we've done thus far. What the first thing we did was to import our data and explain the concept of technical debt, which means if you don't write your code well, if you don't pay attention and think twice before writing your code, if you don't comment on the code, you can create potential debts that even when you leave, they will still be finding ways to address. So while you're solving a problem, you can see create another technical problem for the team based on the project you're working on. And as you continue to equip yourself from beginner to intermediate to advanced, you are bearing that in mind, and that is going to help you do well on your team. The second, after we talked about that, we imported the data, which is about 220 MB large, and we sort of sample it by using stratified random sampling. I'm not so sure, maybe that was a method, but we use statistical method to sample the data to reduce. And after that, we go straight to this notebook where we're importing the data itself. So take a look at it. When you import your data, when you're working on a project, the first place is import your library and import the data. Take a look at the data by exploring it. Oh, building charts and graphs to understand better what to understand better the relationship and whatever exists within this data. And after that, you sort of do all the cleaning. If there's a need to clean anything, replace anything, like doing auth and one auth encoding, just to standardize your data and put them in the format that will enable you to seamlessly train your algorithm. And you also decide, it is hard. What kind of algorithm should I use based on experience, based on what you've done in the past? You can say this kind of unique challenges, I should use this particular algorithm, and set out in case you want to write some functions that will make it easier for you so that I can compare all the algorithm you want to use. And he also talked about upper parameter tuning. Before you start tuning your parameters, sometimes your model can be good without even necessarily tuning the parameter, but most of the time as well, you need to tune them. And the question we are dealing with right now is, as we go ahead to train our algorithm, do you think accuracy is the best way to assess? Accuracy is an evaluation matrix, which is how do you tell that this model is doing well or not? So sometimes you can use accuracy, you can use different, RUC curve, you can use the confusion matrix and check the values within it, which also sort of tell you about the accuracy. You can use root mean square error if you are doing regression. Here we are doing categorical problem now. So different measure of evaluation. But which one do you think is optimal? Do you think accuracy is the best thing to use? That is the question here. And I hope I'm able to summarize a bit. Thank you, guys. So I have a question for you, Nasruddin, while we wait for responses. Okay, so I think this is a question. Why splitting data for training? Isn't stratifying a requirement when particularly you have classes imbalanced? Thank you, Srinivas Vameti, for that question. Okay, so we stratify. The stratification method was to take a balanced sample because the data itself is not balanced. Why? Because about 1% or 0.5% are fraudulent activities, and over 99% are not. And we want to reduce this data. For you to just take 10 of them, you can take 10 out of that 1 million record, and none of those 10 have both categories represented, fraudulent and non fraudulent. So stratified sampling method help us to take that sample in such a way that we have the right proportion of impact of fraudulent activities represented in that data set. So when you're done with that, you still need, before you train your algorithm, you need to split the data, because when you are training, you need to test is this model good before you even introduce it to a new set of scenario outside. And that is why we're splitting our data here. Okay, so and lastly, I think this is an answer to your question, Nasruddin, before you move forward. Srinivas also commenting, thank you, that accuracy, is it the right metric given the objective of fraud detection and also class imbalance? Which is a good question. And obviously, that is the same question Nasruddin is asking here, that do we think accuracy is a good measure given the challenges that we are dealing with. Okay, I'm looking for answers that could solve this. Yes, we can see some conversation in the comment section here that upsample, when you upsample, you can upsample or downsample. Is it done? Of course, we've not touched that. So hopefully we get there, or we might just talk about the concept because it's an art. If you upsample, that doesn't mean you are solving the imbalance challenge immediately, because upsample simply means adding more data, more representation to the sample you are using. Do you have up to that? In scenarios, in real business scenario where you don't even have opportunity to go back and collect more sample, depending on how the sample was generated. How do you address upsample? The sample is more or less restructuring and reducing in case you can get more balanced distribution of your data. What if that one also works? So you try them out. You might not be able to try all this approach out, but a good addition and contribution. And thank you very much. So because of time, because we're making the notebook available, we're giving you opportunity as well to review and optimize this and have the best model possible so that you can actually learn. We're not going to show everything. So Nasruddin, I'm going to hand this over back to you.
Yeah.
Obviously, there are some concern that, accuracy, they're not sure if accuracy is the best metrics, but you can take it off from there.
Yeah, thank you so much, everyone. So we are moving to train algorithm right now. What we are trying to look at is that we want to have a model that is going to be able to save us from cost and be able to detect our fraud, if there is a fraudulent activities or not. So I asked the question, what is accuracy, the right metrics? So we can actually check that and see what will happen overall. Are we even trying to look at this problem the way it's supposed to be? So the reason why I'm trying to pinpoint this is that this will be able to assist us in order for us to know how to debug our models, in order for us to know how to solve a lot of problems. In data science ecosystem research over years, have shown that using accuracy score, just because you are doing a binary classification problem, is not the only right metrics. It's not the only metrics. And it is has been established when you are trying to solve an imbalanced data set problem, accuracy score is never the right metrics to use, because there are a lot of things. Accuracy score is just trying to find what is correct among your prediction. So, and the imbalanced data set, when we are trying to solve the problem, we are trying to find a means to justify the rare case we have in our data set. We want to be able to reduce the rare case. So accuracy does not care maybe there is rare case or not. It just gives us a, okay, this is zero, this is the actual prediction. Has it already solved the problem? So let's look into that, and we have to justify what I said earlier about accuracy from trying to debug our model. So we start with using logistic regression here. We have a logistic regression by default. We try to fit our model using and trying to evaluate our model. Wow, we observe that we have 99.26% accuracy. And then if we cannot go further in trying to debug such model, we are going to feel maybe we have already saved the business, or we have tried to have a model that be able to capture the real case we are looking at. We want to be able to reduce the fraud detection model. So having 99.26% accuracy. So let's check further with our classification report. So we've seen that across the dominant cases, which is zero, we have a lot of high percentage. We have 99% precision, we call the F1 score. But the rare case we want to focus on, the rare case activities we want to capture from our particular ground truth is nothing to be captured. This is 0.001. Automatically, this model has failed despite saying 99.26 accuracy. So can we still trying to look in that particular accuracy score and trying to try a lot of various models in what we want to solve? So checking our confusion matrix, we observe our confusion matrix just capture only two things. It captures the only true negative, people that is being actual, they did not do any fraudulent case and is being predicted with no fraudulent case. And people that is being predicted that actual, they have fraudulent case and being predicted with that fraudulent case. We can see that there is no true positive case where they okay, fine. It is being actual that this person is going to have the trait of fraudulent case and the model predicted one. This is a major problem. And we can be able to observe something here. The model is unable to detect fraudulent activities, which means the model fails and the business must not deploy. So we must be very careful in trying to look at a way. So looking at, we are still trying to focus on particular metric, which is accuracy score. Is accuracy the right metrics? So we try to use the random forest classifier. Random forest classifier as a way for it to be balanced. So because people are talking about undersampling, oversampling, I will try to go to that later on in in the further discussions. So we have the same type of accuracy score here, and we observe that it has the same level of confusion matrix with our logistic regression. So that means that the issue of some models are better than logistic regression here does not really stands to be significant. It's not on 100% is not significant because what logistic regression is seeing is what other models are also seeing. So let's move to the one of the extreme gradient boosting model, SG boost. So we want to look at what SG boost is going to see despite using accuracy as the metrics. So it's been observed again that they have the same kind of traits. The logistic regression, the random forest model, and the SG boost model. They all have the same kind of traits. So one of the various ways in order to tackle problem in machine learning models, when you try to use a particular model that is not solving the problem, ask yourself again, go back to the art. Am I trying to use the right metrics? Am I even trying to frame this problem the right sense for me to be able to even detect even just a fraudulent case? Because all our models, okay, when you have a data set, just throw a model is going to solve the problem. 3 of the models fails perfectly here. So we observe here like all the predicted value are still the dominant cases, and this is a problem with imbalanced cases. So when people comes around, okay, I want to do oversampling, want to do undersampling. When you are trying to oversampling a particular case, you want to make sure, okay, the real cases we have in which is fraudulent activities, you want to make sure it's going to be same balance with the dominant cases. And when you want to try to downsampling that dominant cases, you want to take it to be able to fit in with the real cases. And to be back in fact, there are a lot of research around that. And it does not, it's data science is more of art than science. Most times those things might not work. In the real world sense, it is always lesser for a good company for you to start using machine learning model. You want to reduce the little efficiency problem the human being cannot handle. That's why you are trying to use machine learning solution. So trying to undersampling, oversampling might also be something good. You might try that, but let's move to a providable solution. And one of the way to treat imbalanced data sets is trying to use the right metrics and trying to use the right method. Are we even should we even try to predict, or can we try to predict the probabilities and sit down, check the data set, and find the suitable threshold that's going to solve the problem of trying to capture those fraudulent cases? That's where we are moving to now. So the observation we are having now, the model is unable to detect any fraudulent activities, which means the model fails and the business must not deploy. So therefore, all the 3 models fails roughly. So why the model fails? So there's a little things about the data set is heavily imbalanced, and then the real cases are very small, and the threshold for predict, okay, fine. When it's trying to make prediction, it's less than or equal to 0.5 equal to 0. What next? So we are going to solve the problem now. We are not trying to predict the actual value anymore. We want to make probabilities on the new test cases. So that will be able to give us the chance to be able to bring our intuition and some statistics about in order for us to have a good metrics to solve our problem. So this time around, I'm not going to try to check the 3 models again. I'm going to solve the problems, predicting probabilities, and using their receiver operating costs, AUC curve, and to see how the model will perform. Are we going to have a model that is going to capture a particular fraudulent case in our problem? So now we want to create the probabilities instead of trying to prepare the actual value. And let's check our ROC AUC curve. So ROC AUC score is more similar to accuracy. The higher is closer to 1, the better you seem your ROC curve to be. And we observe that these have around 96% accuracy, and which is 96% score, which is lesser than the accuracy score. But I'm very sure this is a part of the way to handle imbalanced data set. So trying to use the right metrics, trying to use the right predicted values is one of the best way to handle imbalanced data sets. So let's move. Let's try to check what is now being predicted. Automatically looking at our describe function. looking at the statistics here, the average prediction, average probability prediction across all our test sets, which is 3,000, is 0.05. And then this, how they are divided from one another, is 0 plus or minus 0.05. And the minimum, we still have a minimum value of closely to 0. And then we observe that here that we have a maximum value, which is 0.99. Automatically, we can able to find something is moving to closer to 1 here. Something has moved closer to 1. And then our problem have been solved using the right metrics and trying to predict the probabilities. So statistics don't lie. So we have that the most test falls below 0.05, but I'm sure we get it right here. So let's try to, because we want to know the foreign activities, let's try to be able to set the threshold for our predicted value here now. So we want to predict the value. If the predicted probability is less than or equal 0.5, so at least 0.001, a lot of our models, they are 75% of our models, they are below 0.000115. So let's set the threshold here, and then let's check back our conversion matrix. So here I actually used the XGBoost model, which I seems to be the far better model than the previous two model. And let's look at our conversion matrix in order for us to debug our model. So thank you here. So we can see here now that our precision has now increased from the previous one, which is 0.00. We have a recall of 50%. We have the F1 score of 58%. And this record means that, okay, fine. Out of the total people that the ground truth is that, okay, they have only activities. So the model cannot capture the total 50% here now. So let's look at our conversion matrix more better now. We can observe now that people that the model has been able to look at, people that it's actually they do not have foreign activities, and then when we predict them also, they have without foreign activities. They are not different from when we are trying to use accuracy score or predict the rand value. So they are still around 2,973. So let's focus more here on the true positive cases, whereby the predicted is people with foreign activities and the actual is also predicted with foreign activities. This, we have already identified 11 people. We see that we have been able to solve the imbalance problem. Another problem also comes in, which is something that data science actually have to look at. You have the likes of type 1 and type 2 error. This is the type 1 error and this is type 2 error. Mostly in statistics, we are always most careful about this type 2 error. So the type 1 error mostly means the false positive, and the type 2 error mostly means the what? The false negative. So what does the false positive mean? It means that the actual value is that, okay, this particular customer is without fraudulent case, but our model predicts, okay, this has a fraudulent activities. Fine. And the second one is, fine, this particular customer actually it has a fraudulent case, but our model is telling us no, without fraudulent case. We can see we have to be careful about the type 2 error here, because since we have a lower of type 1 error than type 2 error than type 1 error, we should be careful. So here in our conversion matrix, we are not getting it actually right, but we have done something better using the right metrics and predicting the probabilities rather than predicting the actual value. So the next,
so sorry, just for me to cut in right there. What Nasruddin has just explained is very important when you take up any project. The goal is not just to have the most accurate, and that's something we've seen today. It's not about how accurate your model appears. And if you consider this, if you look at this confusion matrix right here, I happen to study statistics from school, so this came alive again to me, the way we relate and address type 1 and type 2 error. If something is fraudulent and you are saying it's not fraudulent, so the model is not doing that much. That's why we are 50%, because out of 22 observation we have right here, 11 out of 22 fraudulent observation. He's saying he's classifying 11 as fraudulent and 11 as not fraudulent, which is just like, I'm guessing, and like, okay, it's fraudulent, it's not fraudulent, it's fraudulent, it's not fraudulent. And if you put your money on these and look at what, if you put your money on this just to say, oh, our model is now predicting what's fraudulent or not, it saves some, right? Especially in scenario where you don't have any solution that is doing that before. it has saved some money, it definitely saved some money, but it might also cause customers some pain points. But let's look how much of customer, 5. Oh, okay, out of that thousands of transactions, it's only say 5 are fraudulent when they are not fraudulent. That's less of pain point. But you might also consider it in that manner in scenarios where the type 2 error is high and type 1 error is significant. So beyond the type 2 error being high, which we see right here, if this same model, for example, even if the type 2 error is low, but type 1 error is high, you have to be careful because that can disrupt the entire business. If the model is classifying more people as fraudulent activity and you are taking business decision that once it is called fraudulent, then that transaction should not go through. Imagine the pains you are causing the same customer you want to, to please. So while you are not losing money, but in recent you are losing money because you are stopping transactions, and the commission on those transactions you are losing them, and the fraudulent, they are not that much. But I just want to say this right, that type 2 error is significant, but you also need to pay attention to how the impact of type 1 error, which can actually cause a lot of displeasure to customer experience. Thank you.
Yeah. So the major observation we have here is our model is able to capture 50% of the misclassified fraudulent case. When we are trying to use the wrong metrics, we are trying to predict the wrong values. So in other way, the threshold being set is 0.5 minor is, I'm not saying it's going to be the optimal values. So this come across you trying to talk the first. Another problem, you have to talk to your stakeholders. So when you talk to your stakeholders, okay, fine. When we try to share this threshold to 0.5, we get this. Is this something that is going to the business really needs? Is this something that is going to scale at the business? If the business says no, then we'll find a way to balance the threshold. And like it's been known, the type 1 and type 2 error is something we should also be careful of, because if you try to say, okay, fine, the type 1 error is not something conducive. Imagine a customer coming, you are telling a customer that does not perform any fraudulent case, oh, you have done fraud. If my customer, you are going to lose the customer, and when you lose customer, you are already losing money. And the type 2 error, people that are trying to have fraudulent case, you are giving them the chance to even to scale the system and telling them, okay, there's no fraudulent case. So we should be careful about the type 2 error. But no matter the fact, we have a model, we have the right metrics that's been able to capture one of the rare cases of having a fraudulent activities. So in a nutshell here, I've been able to make the summary of the first negative earlier and the summary of the first positive. So it is more dangerous than when we try to have, okay, our type 2 error is greater than type 1 error here. And it's also more dangerous when if it's also vice versa. So we should also take note of that in trying to solve a lot of machine learning problems. So these are the ways in order for us to be able to iterate on how to solve problems and how to reduce fraud detection. So the next one is trying to store our models. So I'm not very sure that this model is the one that we are going to take into our deployment phase. But for now, I'm trying to see a way around our models, play into our data set, and be able to find a way to tackle imbalanced data sets using fraud detection. Thank you so much.
Thank you very much, Nasruddin. And at this point, you mentioned something. Can you scroll a bit up? Something very important here under Ask the Business, another problem. So you need to engage while you are doing it. This is very important topic. You don't build it in silo because you have experience building machine learning model. And given the complexity that we've explained, that can actually come in when you're applying this to business. There's a risk for someone who is not fraudulent for you to call that person a fraudulent activity. There's also huge risk for an activity that is fraudulent that you're letting go through your model that, oh, this is not fraudulent. So it involves carrying every aspect of the business along, identifying the uniqueness of business scenarios, and adapting your model to it. So this is very key. And the last thing we are doing is to export this model. We are pickling it, and that's what we're literally doing, storing it in a format like a zip. That's the best way to do it. You zip a file. You are zipping a model now, so that I can take that model that we have trained. Remember, we trained an algorithm, and the resulting algorithm is a model which already have some sort of intelligence. Now, when you throw a data based on that business, it can tell you this activity is is fraudulent or not, but you know that it depends on the evaluation metrics we've used. What we want you to do, because of time, we could not go ahead and deploy this using Azure functions or using machine learning SDK, or we want you to go through this because we have a result that will guide you through this, which is in the 30 days of learning. The link I have with me right here, if you go there, 30 days of data science, which I'm also going to navigate on my screen too. 30 days of, I'm going to share my screen so that you go there. This link is very important. Share my screen, and I'm going to show you where you can actually see the notebook we're talking about. So when you go to that link, it takes you right here to 30 days data science. And this is the roadmap. We're able to see where we are and what we are doing. This is building a fraud detection model. That is what we've done today. The next time is building a classification model. There is a module. For example, if you click on this Learn module, you will see exactly how to build not a fraud detection, but how to do another sample data to build a model and actually deploy the model. So you see even lab assignment that comes alongside with it. So want to go through this, and on the GitHub discussion, go to discussion right here. You're going to see the GitHub discussion where you can ask questions and engage with other learners, and each and every one of you can. That is why we're going to drop the notebook, so you can get the notebook from there. My browser is taking some time to load right now, but on the discussion tab on Discord, that is where you will get the. Okay, I think it is loaded. I just need to authenticate. Yeah, and you can see right on the discussion, 30 days of data science. Within this, we'll put the link so that you can have access to the notebook and review and run from your own end. Don't forget to come here, do your own checklist. What have you done? What have you completed? Activities. And if you have questions, you ask. You see, people are really engaging right here. Okay, so I want to say a very big thank you to you all. Are there questions because of time? Orelua from Futa, thank you. Thank you everyone for joining us. Oh, apologies. I see Rita, you can see my screen. Okay, I need to literally remove this and share my screen. So I've added my screen so that I need to show you. If you go to that link that was projected on the screen, it's 30 days of data science. It takes you right here and you see all the roadmap. Everything we are dealing with, they are here. The sessions we have today is build a fraud detection model. I'm going to zoom here, build a fraud detection model. And tomorrow we are doing this, building a classification models. And this is data set. If you click on Learn modules, it takes you right here to Microsoft Learn. Click Learn modules, take you to Microsoft Learn. And from Microsoft Learn, you see the resources. They also teach you how to build a classification model like what we're doing now. And we're using different data set, but you'll be able to do yours and deploy as well right here. If you go here to the discussion tab on our 30 days of data science it takes you to this page on GitHub where you authenticate. And here you can pass all your questions, your comment, the data, the notebook will be uploaded after this session there. And you can see a lot of people are conversing there, all the checklists for every week, we're adding them here. You know, what you need to cover for the week is amazing. And people are really engaging and discussing. We want you to be there, drop your questions. A lot of people are waiting there to answer and help others as well to navigate their questions. So thank you very much. I think I have shared that. I got to remove this now and back in. Okay. Thank you very much, everyone. Kautara Balogun, just to highlight some of you guys, thank you so much for the sessions. Felix, thank you. Thank you for this amazing session. Awesome, awesome. We appreciate you all. Thanks, Young Innovator Center of Excellence. Thank you from wherever you're joining us from today. We appreciate you. Rita, thank you. Rita Okonkwo, thank you for joining. Thank you, Srinivas, for the lovely contribution you made to these sessions today. We appreciate your depth of knowledge and insight as well. And Trust Franklin, thank you for all the reactions everyone is throwing in right here from LinkedIn, from Twitter, from YouTube. We appreciate you all. Don't forget to follow through. Next week Tuesday, we're going to be converging again for another live session. And I want to meet each and every one of you. Bye for now as I roll up the closing video.